Hello and welcome to another video. So in this video we're going to see about the Kadane algorithm. So Kadane algorithm is an important array based algorithm. So let's see what is the problem it solves. So we have an array which can also have the negative numbers. So we have to find the maximum continuous subarray sum. What it means, like this is a subarray, this is a subarray of the full array, okay, and it is continuous. We cannot take two elements here and the another two elements here, okay. So we have to take the continuous subarray like this one of any size, this one, okay, and we have to find all the possible subarrays. We have to take all the possible subarrays and find the maximum sum out of it. So as it have the negative numbers, so it makes the problem more interesting, okay. So let's see how to solve this problem by Kadane algorithm, okay. So Kadane algorithm says, before going to code, let's see how it works first, then the code will be very easy, okay. So we have to take two variables, final max and current max, okay. So final max is initialized to int min and current max is initialized to 0, okay. So what we do, we will go index by index. So going to the first index, we will have array a is equal to -2, okay. The current max will be the initial current max plus this array, okay, this array element. So it will be -2, okay, as we are dry running the algorithm, which the code I will show later, okay. So the final max is changed when the current max is greater than the final max. The current max is -2 here, okay, and the final max was int min, so it is changed to -2. Now the current max is negative. If the current max is negative, then we change current max to 0. Why is that? Because let's see, what is the current max states that the index which we are in, like we are in the, if we are in the first index, then we say and we are taking the sum from the 0th index also. So we are saying that we are continuing with this subarray. That means this subarray is the potential answer, okay. Now if the current max on the particular index become negative, that it states that like if we continue, whatever the next number is, if it is positive, it is surely decrease it by addition, because it is negative, okay. And if it is negative, the next number, then it will make it more negative. So the subarray will always decrease if the current max becomes negative, comes out to be negative, okay. So we need not to continue with the current max as negative number, okay. So we make it 0. So we are saying that this, if but at particular index the current max becoming negative, that it says that this is not the part of our potential answer. So we have to move to the next index to see our to check whether it is the answer or not, okay. So let's see. So this will be more easy to understand in the further iterations. Let's see. So now our final max is -2, current max becomes 0 as it was negative, okay. So in next iteration, the array have -3, so current max is 0, so we will add it to negative, okay. And it is not greater than the final max, okay. So it will remain -2 and the current max will become 0 as it is negative, okay. So we are saying that -2 and -3, they are not in our answer, okay. So we do not need to find the elements which is in our answer. We just need to find the sum, okay. So let's see. In the next index we have 4, so the current max becomes 4, so it is positive. Now it is our potential answer, okay. So final max becomes 4 as it was -2, so and we did not to change current max to 0 because it is not negative. So the 4 is in our potential answer, okay. The 4 is in our potential answer. So we okay. So let's see. In the next iteration we have -1. The current max become 3, adding 4 and -1, but it is still positive. So we will not change it to 0, as we can encounter a bigger number in the further iterations, and it can change our final max also, okay. So final max is current still 4 because it is not greater than current max is not greater than final max. So in the next iteration we have -2, okay. So 3 plus -2, 3 was the current max in the previous iteration, and we have 1 here. Still final max not changed, okay. In next iteration we have 1, current max is 2, okay. it was previously 1, so still not change final max. Okay, in next iteration we have 5, current max is 2, 2 plus 5 7. Now current max becomes 7. What it is saying, we were continuing with the current max, do not initialize to is 0 from the fourth. That is, we are saying that this is the subarray we are looking for. This is the subarray we are taking. We are not making the current max 0, so we are saying that we will continue with the current subarray. Okay, so 4 is in the subarray, -1 is in the subarray, -2 is in the subarray, 1 is in the subarray, and 5 is in the subarray. Okay, so the sum becomes final max is our answer. Okay, final max becomes 7. In the next iteration we have -3, and 7 minus 3 becomes 4, which is less than the final max. Final max is 7 in the, so finally what we have, after ending the loop, we have final max as 7. That is our answer. So, okay, so now let's look at the code here. The code is very simple. We will initialize it to final max int min, current max is 0. Okay, we will loop through the array, and we have current max is current max, initial current max plus the array element at that index. Okay, and what we will do, if current max becomes greater than the final max will be overridden by the current max, and if it is negative, current max is negative, current max will become 0. Okay, that is, we are declining the current subarray and switching to the next subarray. Okay, so this is the Kadane's algorithm to find the maximum subarray sum of continuous subarray. Okay, so I hope you like it. Like and subscribe. Thank you very much.